Good afternoon, class. My name is James Dag and I'll be your instructor for this evening. Tonight's lesson plan is fire behavior. Before we can discuss the behavior of fire, we must first define it. Fire can be defined as the rapid oxidation of heat and light in varying intensities. Fire is a chemical process whereby a fuel combines with oxygen in the presence of a heat source. This process will continue as long as there is fuel, oxygen, and heat. If any of these three are removed, the chemical process ceases. Another term for fire is combustion. Fire for many years has been discussed in the sense of the fire triangle, which consists of fuel, oxygen, and heat. In recent years, the fire tetrahedron has become increasingly more popular. That consists of fuel, oxygen, heat, and the chemical chain reaction. The fire triangle is now used to represent smoldering combustion. An example of this is a piece of charcoal smoldering in a grill. And the fire tetrahedron is used to represent flaming combustion, like a log burning in a fireplace. In each of these cases, the fuel to burn must be in a vapor state in order to burn. To better understand the fire tetrahedron, we're going to look at each leg independently. First is fuel. Fuel can be defined as anything that will burn in the presence of heat and oxygen. All fuels are composed of matter. Matter is composed of molecules. Molecules is composed of atoms. When you have two or more atoms, we call this a compound. There are two types of compounds, organic and inorganic compounds. Organic compounds help in the combustion process, whereas inorganic compounds do not. All fuels will burn, but not all fuels burn at the same temperature. If a fuel meets an ignition source, like a flame, it will ignite. However, that same fuel will ignite if it reaches its ignition temperature. The ignition temperature is the minimum amount of temperature a fuel needs to start self-sustained combustion. The next leg of the fire triangle that we will discuss is oxygen. For a fire to occur, there must be 13% oxygen present. For visible flame, there must be 15% oxygen. Oxygen is the key component in the chemical process. The more oxygen, the bigger and more intense the fire. The less amount of oxygen, the less intense and smaller the fire. The last leg of the fire triangle is heat. Heat is a form of energy and is measured in temperature. There are two types of temperature, degrees Fahrenheit and degrees Celsius. Heat is also measured as the amount of matter of energy output. That is measured in British thermal units, or BTUs. BTUs is defined as the amount of heat needed to raise 1 pound of water 1 degree Fahrenheit. Heat can also be considered as matter in motion. All thing has heat, regardless of how low it might have. The more heat involved, the higher the matter is in motion. The less amount of heat, the slower the molecules are. Heat will always transfer from the hotter object to the cooler object. This is the law of heat flow. Heat can travel in one or more of three ways: convection, conduction, and radiation. The transfer of heat by the movement of air or liquids is defined as convection. Conduction is heat conducted from one body to another by direct contact of the two bodies or through a heat connecting medium. Radiation is the method known of heat radiated from one object to another through heat waves. Now that we've discussed the fire triangle, let us discuss the different stages of fire. There are four: the ignition, the growth, the fully developed, and the decay stage. First, we will discuss the ignition stage. This is the physical act of igniting the fire. There is adequate fuel. Oxygen is between 18 to 21%. The act of ignition can be caused by a spark or through a material reaching its ignition temperature. The fire is small and confined to the material first ignited. The next stage is the growth stage. From this point, the fire begins to grow. This was previously called the incipient stage. Growth of the fire is based on several factors: oxygen supply, fuel, container size, and insulation. Between the growth and fully developed stages, some consider flashover to be a stage of its own. Flashover occurs when flames flash over the entire area that is burning. The cause is the buildup of heat from the fire itself. Through a process called radiative feedback, the fire heats up nearby materials through the radiant heat. These materials, in turn, heat up other materials and also send radiant heat bank to the fire source, causing the heat source to increase in intensity. As this occurs, all material in the room is nearing its ignition temperature. Once the ignition temperature of all these materials is met, the room or area seems to ignite simultaneously. The next stage is the fully developed stage. This is the point where all contents within the perimeter of the fire's boundaries is involved in the fire. The intensity and the rapidity of the speed will depend on whether it is an outdoor or compartment type. For an outdoor fire, the spread will be dependent upon the amount and configuration of the fuel. For a compartment fire, the spread will be more dependent on the amount of oxygen the fire is receiving. The final stage of fire is the decay stage. This is the point where all the fuel has been consumed. There's no more large flames as in the previous stage, only small flicks of flames, and these will diminish also. All that will be left will be glowing embers. If the fire department does not arrive to control the fire, it will go to the decay stage and ultimately burn itself out. Now that we've discussed the different stages of fire, we can now talk about the different classes of fire. There are 5 classes of fire: Class A, Class B, Class C, Class D, and the newly established Class K. Class A fires are fires that involve ordinary combustibles such as wood, paper, cloth, rubber, and many plastics. Class B fires involve flammable or combustible liquids. Some examples are gasoline, diesel fuel, paints, lacquers, alcohol, propane, and natural gas. Class C fires include any electrically energized equipment. Some examples of this are household appliances, transformers, overhead electrical transmission lines, and others. These fires must be controlled by extinguishing agents that are non-conductive agents. Specifically, do not use water or foams since they are conductors of electricity. Class D fires involve combustible metals such as magnesium, titanium, zirconium, and potassium. The final class of fire is Class K. This involves cooking materials such as cooking oils, fats, and grease. And that concludes our lesson for this evening. For those of you who paid attention, thank you. For those of you who were so broke you couldn't pay attention, please rewind and play again. Thank you.